Carbon fibre is a material that's absolutely revolutionised bike frame design. It's enabled engineers to build frames that are lighter, stronger, and in far more complex shapes than they could previously with materials like steel and aluminium. But how are carbon fibre bikes actually made? Well, to find out more about the manufacturing process in more detail, we've teamed up with Look, and we've come to Tunisia to visit their carbon fibre bike factory. Now, Look is a company with a huge heritage in carbon fibre bike design. They have a well-earned reputation for innovation and cutting-edge design. But before we go any further, I think we should have a quick science lesson about carbon fibre and also learn a bit more about the heritage of Look. So to do this, we'll teleport back to Look's HQ in Nivelles, France. We're here in Nivelles, France, which is where Look designs and prototypes all of its carbon frames. Now this is an incredibly complex and intricate process, and a common misconception with carbon fibre is that, well, steel frames are handmade and steel is real and carbon fibre frames are perhaps not. Well, that's completely not true. Building a carbon frame is incredibly labour intensive and complicated, and that's one of the reasons why they're expensive. Because behind me, this isn't just a funky wallpaper design, oh no. This is all the individual parts of carbon fibre that go into making a Look 795 Aerolite frame. There's over 300 individual bits. It's absolutely mind-boggling. It's just, it's a very complicated jigsaw puzzle. And what's even more impressive is that the latest Look, the 795 Blade RS, has 405 individual carbon parts. Carbon fibre is an incredibly versatile material to make bikes from because of its material properties. So here we have some individual strands of carbon fibre, and in one direction they can be incredibly strong, yet in another direction they can bend and be flexible, which can be really useful. For example, if you're building a chainstay, because you want it to be incredibly strong laterally, but in the vertical plane you want it to have compliance so that you've got comfort built into your frame. And by carefully considering and manipulating where they put the carbon fibre and how they orientate it with different layers on top of one another, you can actually tune the frame to be exactly stiff where you want it, but also exactly compliant where you want it too, and keep it very lightweight all at the same time. It's impressive stuff. So I want to show you something really cool just over here. To demonstrate how carbon fibre can be laid up to be stronger in certain directions, Look have created, well, this really clear display. So what you have here is different modulus carbon fibres, and also we've got steel and aluminium in there as well, and they've been laid up in different ways. So each weight that's hanging off the end of each one of these rods is exactly the same mass. Now, here you can see that the deflection in this rod is far less than the deflection in this rod. Now, the reason for that is because the carbon has been laid up to be stronger on top of itself in this rod, whereas in this one, it's not been laid up in that way. You can also see that aluminium is deflecting more than carbon as well, so aluminium is less stiff. Also steel as well, you can see the steel is deflecting more. The really important thing to point out here is that you can't just build a bike out of carbon. You can't just slap carbon together and expect it to be a good bike. It really is about how you manipulate that material and how you actually lay it up and the orientation of how you lay it up. And that's where Look has lots of expertise, because the same mass of carbon fibre is used here in this rod, which has loads of deflection, as there is in all of these other carbon rods as well. So you can see it's really important how you lay that carbon up. Look's pedigree in carbon fibre bikes is absolutely unrivaled. This is the KG86, and it was the first carbon fibre bike to win the Tour de France when it was ridden by Greg LeMond in 1986. The clue is in the name. It was also ridden by Bernard Hinault as well. And it's got carbon fibre tubes that are reinforced with Kevlar with these aluminium lugs in the construction as well. It's an absolute beauty. So now I'm going to click my fingers and we're going to fast forward to the latest bike that Look have introduced. And so we come to the present day and this absolute beauty, the Look 795 Blade RS. It's the culmination in all of Look's expertise in carbon fibre bike design. It's their latest model and, as I mentioned, features over, 405 individual carbon fibre pieces. So I think we're going to go see how it's put together and how it's made back in Tunisia. That was quick. So, we should first start with carbon fibre. Back in France, we showed you those individual strands and filaments of carbon. Now they are combined into large, huge rolls of carbon fibre, which is then impregnated with an uncured two-part epoxy resin to form the composite material. This is known as pre-preg carbon, and it comes in huge rolls, which you can see behind me. There are different kinds of carbon too. So some carbon fibre has a weave pattern in it, like this, whereas others, the fibres are all arranged in the same direction and are unidirectional, like this one. And the modulus can vary too. The modulus refers to the stiffness of the individual fibres, and higher modulus carbon fibre is achieved by continually refining each filament within the carbon to make it thinner and smoother. Now, higher modulus carbon fibre can be stronger, but it's also more brittle. So the best carbon frames use a combination of different fibres in different locations. The majority of carbon used in a frame like the Blade is unidirectional, and this is because it has higher specific properties and is also easier to lay up in a specific direction. Woven fibres, like this, are better suited to more complex geometry locations where the loads are less well defined. So areas such as the head tube, the bottom bracket, and also any joins in the frame will employ this. And also areas where holes have been drilled into the frame, such as bottle cage mounts or say where the derailleurs are attached as well. The key thing to stress is that making carbon frames requires a huge amount of skill, expertise, and design. It's a bit like cooking in that you could have the same raw ingredients, this roll of carbon, and you could give it to me, and you could also give it to a Michelin-starred chef, but the end result would be, well, very different. The big rolls of carbon fibre are first cut into sheets, and then the individual pieces of each frame are cut out of those sheets, and that's done by a combination of, well, by hand, as you can see behind me, but also by a CNC profiler. And by using that, they're able to minimize wastage in the sheet and just maximize every single square inch of that sheet. The next step involves taking those individually cut pieces and assembling them in what is, well, like a really complicated 3D jigsaw puzzle, where the exact order and placement of those pieces has to be really specific. Now, going back to our science lesson, this takes advantage of the properties of unidirectional carbon fibre. Some pieces are laid up in one direction, while other pieces are laid up in an opposing direction in order to create strength in that direction, because that's the direction the fibres are running in. And this enables Look to make really light and strong frames, but also size-specific frames too. The workers here make it look very easy, but in untrained hands, it's an incredibly fiddly process, and it's so time-consuming. Just to remind you, this is a Look Blade frame. It has 405 individual pieces, and they have to be laid up in a very specific order and place. It's impressive. The individual pieces are laid up around bladders and preformers such as this, as these form a crucial part of the moulding process, which comes next. But how does Look decide where to put the individual pieces and the different types of carbon fibre? Well, that involves an immense amount of knowledge, skill, experience and design. And one of the ways in which they do it is through mechanical testing back in France. So I think we need to teleport back to France to see how they do it. If you're a bike frame, going into this room is your absolute worst nightmare. But fortunately, I don't think any of you are bike frames. So let's go in. You're going to have to forgive me in here while I raise my voice and shout slightly, because I'm having to talk over the tortuous screams and wails of dying bike frames over there that are currently being tortured. So this is the sprint test machine, and this machine measures the torsional stiffness of a bottom bracket, and it does this by having 120 kilogram weight on each side, replicating each pedal stroke, and it does this over 2 days with 100,000 cycles. So using this machine, Look can actually measure the deflection in the frame and then use this information to develop its frame designs and prototypes in the way that we talked about earlier with the different ways that carbon fibre can be laid up. So by changing the way that they lay up the carbon fibre, they can reduce or increase the amount of deflection in a given part of the frame, whether that's to increase stiffness in certain areas or increase comfort in other areas. We've seen how Look tests prototypes here in Nivelles, France. So now it's time to teleport back to Tunisia to see how the individual pieces are put together to mass produce the carbon frames. Teleport time. We're now in the area of the factory where the moulding takes place. Now you'll have to excuse the noise because this is a working factory floor. But Look takes the layups with the bladders and preformers inside and places them in giant moulds, like the one you can see the guys working on behind me just through there. Now the way it does it is through a modulus monocoque construction. And what that means is that you have a large part of the frame, like this single front triangle, is constructed separately from the seat stays and chain stays and fork. Those pieces are done separately. And at a later stage, the stays are glued in place and fixed with some carbon. The mould is then placed in this massive heated press, which applies 2 to 10 bars of pressure incrementally over 45 minutes at 170 degrees. This is known as debulking. Heat and pressure is applied to the outside of the frame while the bladders inflate on the inside of the frame, pushing it outwards. This heats the resin and allows it to flow evenly through the layers and also eliminate creases and force out air gaps, which can cause voids and points of weakness. After the moulding process, the frame is left to cool for 50 minutes before it's removed from the mould. And when it's removed, any excess bits of resin or stuff that are on the edges of the frame are trimmed off. And then you get the frame like this here. But note it still has the preformers attached inside. The next step is to put it in one of these giant ovens where it's, well, baked. And this is a process done to cure the resin in the frame and remove any remaining moisture or air gaps that are in the frame. And this is a process that's a bit similar to what you do with pottery, when you fire pottery in a kiln. Next up is the beginning of the surface preparation of the frame. And this involves, well, sanding it down as it's come out the mould. So this is what it looks like after it's been moulded and baked. And after the initial surface treatment, this is what the frame looks like. You see it's quite different. It's at this point where the preformers and bladders are removed from the carbon frames, and then the surface treatments begin. All these boxes are filled with different carbon components that are going to be surface treated and surface prepped. So there's loads of like different sized chain stays and seat stays. And look at this, it's a box just full of Look carbon cranks. So many of them, look at them. Next comes the machining process, and this is where all the little holes are drilled and milled into the frame for little details such as where the derailleur hanger goes or little cable holes. So in case you were wondering, like me, what happened to Arnie's robot arm at the end of Terminator 2? Well, the answer is that Look actually acquired it and put it to use in its factory to machine holes in frames for cables. After the surface preparation and machining, the next step is to join the different finished parts together to make the complete frame. So you can see here that on this frame, this is where the stays are going to be attached. And you may notice that this area is actually recessed. Now there's a good reason for that. So when the parts are combined, a separate piece of woven carbon fibre is attached over the top. And this is to add strength and, well, strengthen the area. Now, because it's recessed, when you add that extra layer, it means that there's just a nice, continuous, smooth line and not a sort of lump in the finished product. The dropouts and stays are actually glued in place using a special carbon fibre glue, which is then put in an oven for an hour and cured at 90 degrees. Now, to make sure that everything's in the exact right place, this is all carefully assembled on a special jig, which clamps all the pieces in the exact right orientation so that the precision is spot on. Next comes the surface finishing and preparation. Now, at every step of this process, the builders are meticulously checking each product and component for the slightest flaws and imperfections. And even the slightest mark can result in a product being either recycled in the manufacturing process or rejected entirely. The bare matte carbon frame, once it's been fully cleaned and sanded down, is then varnished with a clear coat. And you can see behind me, that frame's been varnished, and it's quite strikingly different once it's been varnished to the matte carbon before it. But even when it's been varnished, it still needs to be surface finished, again, by hand and smoothed and polished, ready for painting. Behind me here is where the frames and also other components too, such as handlebars and chain sets, are actually varnished. And after this, some of them are painted by hand here in Tunisia, but some other certain models are painted back at Lux HQ in Nivelles in France. So I guess we should head back to Nivelles to see the frames being finally painted by hand and assembled into complete bikes. So let's teleport. What do you mean we can't teleport back? Well, I don't care if the GCN teleportation budget has been used up. All right, well, I guess I'll just have to run. See you in a bit. That's a long way. So, we're back now in Nivelles in France, and the frame sets come back here from Tunisia, where they're now painted and covered in the final decals so that it can either be sold as frame sets or, in some cases, complete bikes to you or I. The painting process is more complicated than you might imagine. So the surface of the carbon has to be rubbed down and treated first, upon which then layers are applied. So there's primer coats and base coats, and then in this case we have a white frame to which then decals are applied. Now the decals are actually designed and printed in-house here by Look, and they're basically like a really sort of posh version of the transfers that you would have got in a model sort of aeroplane kit if you ever made one of those when you were a kid, or maybe you still make them today. And then after that, a lacquer coat is applied over the top to sort of seal everything in and protect it and make it easier to clean as well, rather than just a raw sort of matte finish. We're now here at the end of the production line, and these are finished Look 795 blade RSs that are ready to be shipped to very lucky consumers. They're absolutely beautiful in the white there, with the Mondrian nod there with the blue, yellow and red on the frames. And if you're interested in what this bag is on the end, that's actually all the bits and accessories that you'd need to build this if it was sold as a frame set. Look do actually also sell them as complete bikes too, but quite fancy one of them. I might try and steal one in a minute. I hope you found this video useful and informative, and if you have, then please give it a thumbs up and subscribe to the Global Cycling Network. I, for one, have been absolutely fascinated in seeing how carbon frames are both developed and laid up and put together. And it's nice to see that This is a really intricate process that requires loads of technical knowledge and expertise, and isn't simply a case of loading up a hopper with a load of granules and then injection moulding a carbon fibre frame out of a machine. It's just incredibly technical, both on the development, but also the skill and hours that are taken in laying up all those individual pieces. If you'd like to watch another video, then I suggest, well, we've just seen how carbon bikes are made, so how about how steel bikes are made? If you want to watch that, click down here.